this video, we are going to discuss few problems on Gauss divergence theorem. Verify Gauss divergence theorem for f vector equal to 4x z I vector minus y square j vector plus yz k vector over the cube bounded by x is equal to 0, x is equal to 1, y equal to 0, y equal to 1, z is equal to 0 and z is equal to 1. In this problem, just we are going to verify the Gauss divergence theorem statement for in this f vector with the region this cube is given with the values x0 1 y0 1 0 to 1 and z is equal to 0 to 1. Okay, in step 1, first write clear statement like this: double integral over s f vector dot n cap ds equal to triple integral over v del dot f vector into dv. Okay, now we are going to prove the left hand side value equal to right hand side value. The left hand side part is nothing but surface integral, right hand side is volume integral. Okay, actually the Gauss divergence theorem statement is relation between surface and volume integral. Okay, in step 1 write clear statement and then in step 2 draw the diagram. Okay, cube diagram with the distance 0 to 1. X-axis, Y-axis, Z-axis, okay, this is the cube diagram. Okay, and then first we can take our left hand side part, LHS. Left hand side of our statement is double integral over s f vector dot n cap into ds. In this cube we are having 6 surfaces. Okay, first one is start from this side, this one. First one is front side, surface 1. Okay, and then opposite side, surface 2, back side. Okay, surface 3, right side, left side, surface 4, top. Okay, this one is S5, bottom side is surface 6. All the 6 sides are closed. Okay, in the left hand side part we have to find the value for 1 by 1 from S1 to S6 all the values. Okay, before we start to solve the problem, first if we form one table, okay, if we form one table like this, we can easily find the solution. Okay, integral over s f vector dot n cap ds is equal to double integral over s1 plus s2 plus s3 plus s4 plus s5 plus s6 f vector dot n cap into ds. We have to calculate each surface separately and then finally if we are adding all the 6 surfaces we will get the required left hand side value. Okay, surface 1 to surface 6 we have to calculate separately. Okay, this is our given f vector. Now we are going to start from surface 1. Surface 1 is front side. Okay, this one is surface 1. Here n cap, first column wise 1 by 1, right? In the first column write surfaces 1 by 1, s1 to 6 all the surfaces. Second column n cap, that is a unit normal vector, outward normal vector. Third column is f vector dot n cap, multiply with the f vector. After writing the n cap here, multiply with the f vector, we will get this column and then equation, a given equation only we are going to write here ds and then finally we have to calculate the value for this one. Okay, first if we form this table like this, we can easily integrate one by one. Okay, first we can take surface 1. Here surface 1 means front side, this is S1. Here unit, this one is lies on the x-axis. Here unit outward normal vector is I vector, written here I vector. And then f dot n cap. What is our f vector? 4xz I vector minus y square j vector plus yz k vector dot n cap. What is n cap on S1 is I vector. Multiply taking dot product for these two terms, j dot I 0, k dot I also 0. Only we will get the first term because I dot I value only 1, which is equal to, we can write 4xz. Written here 4xz. Okay, equation. This equation is nothing but from the origin, here x distance till this value is 1 written here. ds is actually, here ds is this one is lies on the x-axis. We have to write dy dz by modulus of n cap dot I vector. Okay, here n cap is I vector already written, I dot I value 1, that's why we are getting only dy dz. ds is dy dz. And then substitute here double integral f dot n cap. F dot n cap is 4xz ds. Actually 4xz here will come. Here x value is 1. That's why substitute here x is equal to 1. We are getting only 4z. 4z dy dz. Okay. In the similar way, we have to write for all the surfaces one by one. Next, surface 2. Surface 2 means just back side. Okay, this one is front side surface 1, back side is S2 surface 2. Here unit outward normal vector is minus I vector. Minus I vector means just we have to replace here minus. Minus means here we'll get one negative sign, that's all. 4xz. Equation here x is equal to 0 because this one is YOZ plane, opposite side. Obviously x values here 0 only, 0. And also ds will be same. Then here f dot n cap value minus 4xz. Anyway, x is equal to 0 means we will get 0 here. Right here 0. And then take S3. S3 is right side, this surface S3. This one is lies on the y-axis. Here n cap is j vector. Okay, n cap is j vector. J vector means here we have to replace j vector. J vector means dot j vector. First and third term will be 0 because I dot j, k dot j values are 0. We will get only the middle term, only minus y square. Written here minus y square. Okay, and also y equal to 1. From the origin, y distance will be 1. ds is dx dz. This one is y axis, no? dx dz divided by n cap dot j. N cap is j, j dot j value 1, we will get dx dz. And then substitute here double integral f dot n cap is y square minus y square. Here y value 1, substitute here, we will get only minus 1 dx dy. Limits will be same. X limit or y limit or z limit. In the given problem, he has given clearly x varies from 0 to 1, y 0 to 1, z also 0 to 1. You no need to check the limits. Okay, 0 to 1, 0 to 1, we can write directly. And then S4. Take S4, surface 4. Surface 4 is just opposite side, left side. This one is surface 4. Okay. On surface 3, n cap is j vector means opposite side here n cap is minus j. Here minus y square written no f dot n cap. Here add on negative sign, we will get positive, which is y square, which means here minus will come, here plus will come. That's all. Y value 0 because this one is xy plane, here y is 0. And then ds will be same dx dz. And also substitute here f dot n cap is y square plus y square. Y 0 means we will get only 0 here. Okay, and then surface 5, this one top lies on the z-axis. Here n cap is k vector. Okay, f dot n cap, here k vector means substitute here k vector. Substitute here k vector. Dot k vector means first and second term values are 0 because I dot k, j dot k 0, we'll get only the third term. Y is z written here. Okay, z is equal to 1. From the origin, distance will be 1. Z is equal to 1. ds is dx dy. Here actually dx dy by n cap dot k vector will come. Here n cap is k vector, k dot k value 1, we are getting only ds dy. And also Substitute here, double integral y is z. Here z value is 1. Substitute here, we will get only y. ds is dx dy, and also limits will be same, 0 to 1, 0 to 1. Okay, last one, surface 6, bottom side, xy plane. Unit normal vector is minus k. F dot n cap is, we have to add on here negative sign. Here also one minus will come, minus y z. The xy plane means z is 0. ds will be same. F dot n cap is minus y z. Anyway, z is 0 means we will get 0. Okay. If we form this table, hereafter we can easily integrate. First we can take our surface 1 value. Surface 1 double integral S1 f vector dot n cap ds. Here we already written. Take this one, 4z dy dz. First integrate with respect to y dy. Here 4z constant, right here 4z. dy will be y, limit 0 to 1 into dz. First apply upper limit value 1 here. 1 minus 0 will come, that is 1. There is no change here. We will get only 4z. Integral 0 to 1, 4z dz. Now integrate with respect to z. 4 into integral of z dz will be z square by 2 with the limit 0 to 1. And then substitute here 1, we will get only 1. And then 2 cancel, we will get 2. Okay, surface 1 value is 2. And then next surface 2. Already we written here surface 2 value is 0 only. We can write directly double integral over S2 f vector dot n cap ds is equal to 0. Next surface 3. Surface 3 is double integral 0 to 1, 0 to 1 minus dx dz. First integrate with respect to dx and dz, will get the answer. If you are integrating this minus x 0 to 1 dz, then apply limit 1, we will get 1 only, minus dz, and integrate, we will get z 0 to 1, answer is minus 1. Surface 4 value is 0 because surface already written here 0 means the integration value also 0. Then take surface 5, this one, double integral y dx dy. First integrate with respect to x, we'll get x 0 to 1 dy, y into apply the limits, there is no change here, only y. Integrate with respect to y, y square by 2, 0 to 1. Apply the limits, we'll get 1 by 2. Surface 6 value is, integral value is 0 because already we written here 0. Okay. Now substitute 1 by 1 all the values here. First surface 1 value 2, surface 2 0, 3 minus 1, 4 0, 5 is 1 by 2. Then final last 6 value is 0. If you are adding all the two terms, 2 minus 1 will be 1, 1 plus 1 by 2 will be 3 by 2. Our left hand side value is 3 by 2. In the similar way, we have to prove our right hand side value also 3 by 2. Right statement of our right hand side part is triple integral over v del dot f vector into dv. Okay. First we are going to calculate del dot f vector. If we calculate this one, we can easily integrate. We know that the expansion of del I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z into dot f vector. This is our given f vector. Taking dot product for these two terms, which means first term this into this. I dot I value 1 dou by dou x of 4xz. And then next second term this into this, j dot j value 1 plus dou by dou y of minus y square. Third term will be plus dou by dou z of yz. K dot k value is 1. If we differentiate with respect to x first term, x will be 1, we will get only 4z here. The second term minus 2y written here. Here differentiate with respect to z, z will be 1, we will get only y plus y written here. 4z minus y. Del dot f vector value is 4z minus y. Hereafter we are going to do only normal integration only. Triple integral over v del dot f vector dv equal to, we can write integral 0 to 1, 0 to 1, 0 to 1. All the values will be same. X varies from 0 to 1, Y varies from 0 to 1, Z also varies from 0 to 1. You no need to check the limit. Okay, del dot f is 4z minus y into dv. dv will be dx, dy, dz. Now first integrate with respect to dx. Here there is no x, which means we have to consider as constant temporarily. 4z minus y into x. Apply the limits 1. There is no change in 4z minus y. Again we are getting the same term. Now integrate with respect to y. Y means 4z here constant. 4z into y will come. Integral of y will be minus y square by 2 to the limit 0 to 1. Now apply our upper limit value 1 in y. We will get 4z into 1 minus 1 by 2. Then lower limit value 0. Now finally integrate with respect to z. Integrate with respect to z means first term is 4z. We are integrating with respect to z here. 4 into z square by 2 minus 1 by 2, which means z by 2 with the limit 0 to 1. Here we can remove this 2, we'll get 2 times of 2 into 2, 4, we'll get 2z square here. 2z square minus z by 2 will come, and then apply upper limit value 1 here. If we put here 1, we'll get 2 into 1. Okay, 2 into 1 minus, here substitute z is equal to 1, 1 by 2. 2 minus 1 by 2 is 2 2s are 4, 4 minus 1 by 2, which is 3 by 2. Okay, 3 by 2. Therefore, LHS equal to RHS. Hence, Gauss divergence theorem verified.